hello and welcome to another video in the series. Today we're going to be looking at the Monty Hall problem and game show theory. That is actually a mathematical thing. And you've clicked because you're curious. Would you change? If you're not curious, keep scrolling. Have a great day. So the problem would be, there's three doors. I'd be the game show host. There are prizes to be won. But behind one of the doors is a brand new car. And behind two of the doors is a bag of sand. And I know where the car is. And this is important because I know where the car is. So let's say, I won't give away where I'm going to say it is now, but let's say the person, you play the role of the person, the contestant, you've chosen door number one. Now, if you've chosen door number one, I know where the car is, and I say, well, I'm going to help you out here. I'm going to open a door and show you a bag of sand. So visually, I'm just going to get rid of the door. So now we've got two doors left. So would you switch? You chose door number one originally. I've opened a door, shown you it's a bag of sand. Would you switch to door number two? There's the question. But before I answer that, because there is a mathematical reason behind switching or not switching, I'll try it with a few more doors. So as you can see here, I've got 10 doors. So let's do the same thing, okay? Let's say you choose straight away door number 5, okay? Door number 5. I know where the car is and there are 9 bags of sand. So I say, okay, let's get rid of it. So you've chosen 5. And I'll leave 2 doors. Would you switch? Okay. Now, I could go one step further, but I can't draw 1,000,000 doors on the board, right? If there was 1,000,000 doors and there's one brand new car and I know where it is, and you pick a door and you open up and I open up and show you loads of sand, and I leave 2 doors right at the end. So there's 2 doors left out of the 1,000,000 original. Would you switch? Okay, and that is the Monty Hall problem. So if you've chosen to switch, if you've chosen to stick with your original choice, you have made a mathematical error. And let me break down the maths for you. We said on the first one, if you chose door number 1, there were 3 doors originally. So there was a 1 out of 3 choice of being right. There was a 2 out of 3 choice of being wrong. So because I know where the car is, all of the probability gets put into this final door. So there is a 2 out of 3 chance that the car is behind this door. So mathematically, you should switch, because there is a higher probability that you guessed wrong originally. That's emphasized better in the 10 door situation. So you picked door number 5, or I said for you, you picked door number 5. There is a 1 in 10 probability that the car is behind that door. But because I've eliminated all the other bags of sand, behind this door, there is a 9 out of 10 chance that the car is there. Because what we're saying is that the chance of you guessing the car right straight away is 1 out of 10. But me eliminating all the other probabilities, having known where the car is that. And that's the same with the 1,000,000 doors. There would be a 1 in 1,000,000 chance of you guessing the right door straight away. And because I know where the car is and I'm eliminating the doors, there would be a 999,998 chance that the car is in the other door. So you would obviously switch. All right. And it's so going right down to 3 doors, you would switch. Some people wouldn't be too bothered. There's only 3 doors. You might stick. Yeah. You've got a 1 in 3 chance. But as the numbers get bigger, then you are more likely to switch. So that's the Monty Hall problem. So if you ever get offered that, switch. Ask them to put more in. Make the probability greater. The other thing, okay, so I tried to link this. I was trying to think, well, what's similar? What's on TV that's similar? Deal or no deal? Deal or no deal? And I thought, right, is this the same? And as it happens, it isn't. It isn't the same. I wanted it to be, but it isn't the same. Deal or no deal, there's 20 boxes. You pick a box. You're hoping it's got 500k in it. There's a 1 in 20 chance you pick that box. You play the game, you eliminate boxes, you speak to the banker and whatever. and you're left with two boxes. Let's say number 4 and number 18. Number 4 is your box, number 18 is the other box. Well, Noel doesn't know what's in the boxes. The banker doesn't know what's in the boxes. Let's go wild. Let's say one of them's 1 penny and one of them's 500,000. In this situation, it is not the Monty Hall problem, because the probability of you picking the 500,000 is 1 out of 20. But the probability of you picking 1 penny is also 1 out of 20. The elimination is random. So the probability doesn't change. So by the end of it, there's still a 1 in 20 chance in each box. And that's where game show theory comes in. And I'll just give you a little snippet of that, because I don't want the video to be too long. So game show theory is, for example, the banker here will give you an offer. And bearing in mind, you have gone to this game show with nothing. So the offer will be between a penny and 500,000. Probably a life-changing amount of money. But people get into the show. They want to gamble. They want to go for the high money. But realistically, you've gone with nothing. Even if you offered £10,000 between 1 penny and 500,000, statistically speaking, the best thing to do is take the offer. There is a 100% chance you could come home with money, or there is a 50% chance. And this is how we talk about them statistics and probability that we've done in the last video. So that's where game show theory comes in. It's something you can study at university, and the psychology behind the decisions people make on game shows. It's fascinating. So yeah, I hope that's piqued your interest a little bit. If you're like me and watch game shows, you don't really watch it for the game show. You watch it for the maths. So anyway, Monty Hall problem. Hope that's been explained for you. And I hope you will switch, should that be the case. But deal or no deal, do your own thing. Have a great half term.